Okay, quadratic equations and graphs, we'll do some more review. This example says graph the parabola in part A and then use the graph to solve the equation in part B. So we're going to do everything graphically, which means first I have to graph this equation right here. So I'm going to make an XY chart. And I'm going to put in some x's, like let's say -2, -1, 0, 1, 2, and I'm going to replace the x right here with those values, and then I'm going to pop out the y values. So I have -2 squared. Order of operations says square the -1/2 first. That's going to be a +2, or the -2 first, I'm sorry. Remember the 2 applies to this. So -2 times -2 is a +4, and the half is waiting outside, and half of 4 is 2. We do the same thing for the other ones. So we spit out all the y values by plugging in the x values accordingly, and we get 1, 2, 3, 4, 5 ordered pairs. That should be enough to graph this line, or graph the parabola, I'm sorry. The first ordered pair is -2 and 2, so left and up. Next one is -1 to the left and only halfway up. So if this is going to be a 1, halfway up is the y value. Then I have 0, 0. Then I have 1 to the right, only halfway up, and then 2 to the right, and 2 up. So that should be enough to help me graph this parabola. Now the next part says use your graph to look at what the solution to this equation is. That's what it said. Use the graph to solve part B. Now part B tells me when is this parabola going to have a y value of +8. So I have to go to the y-axis and look at when the y-axis is going to become a +8 and hit my graph. So 6, 7, 8, that's a y value of 8. I make a horizontal line through 8 to see when it hits my graph, and it looks like I need to continue with my graph to see when it hits it. So my graph goes up and to the right and goes up and to the left. So I'm sort of approximating what's happening here. It looks like it hits the y value of 8 here and here. And based on the symmetry that's going on here, how the x values give me y values that are mirror images on both sides, I'm seeing a -4 for the x value on the left, and on the right side something close to 4. So I'm going to guess and say 4, even though it looks like 3.5 on my graph. Maybe my graph is not accurate enough. Maybe I should have gone on and put in some more values to see what happens. Or maybe I can check my work algebraically and see what happens. So I'm just going to go and sort of cheat, since my graph doesn't seem too accurate, and do it algebraically. So I have a half x squared equals 8. I don't like that fraction. I'm going to multiply both sides by 2. That's going to give me x squared equals 16, and now if I square root both sides, I get x equals ±4. So I was close. I was getting to two values of ±4 based on my graph. It just looked like it was maybe 3.5 because my graph wasn't accurate enough. So if I had an accurate graph, I would see that it hits the y value of 8 at the two different places with x coordinates 4 and -4. Same directions here. It says graph and then use your graph to find the solution to part B. So I'm going to put those values and see if they're enough to give me an idea of what's happening. So go put them right here in the place of the x. 6 minus 2, plug in a -2 squared. That's going to be square the -2 first. So 6 minus 2, remember order of operations, pops out a 4. And that's going to be 6 minus multiply, that's an 8. So that pops out at -2, and I'll do the same for the rest. Okay, we have all the inputs, we have all the outputs. I made the ordered pairs, and now I'm going to go graph them. -2, -2, so if this is the origin, down and left. Then I have -1 and up 4. Then I have 0, 6, so 1 above 5. Then I have 1, 4, so 1 to the right, 4 up. And then 2, negative 2. 2 to the right, 2 down. And so let's hope I have an accurate enough graph. It's going to go down like that. Now part B says use your graph to find when this parabola is going to have a y value of 4. So I have to go find the y value of 4 and then make my horizontal line through it. If that's a y value of 5, this must be a y value of 4. And I make my horizontal line through 4, and it gives me 2 corresponding x values, which happen to be pretty exact. I can see them to be 1 and negative 1. So my guess is that the solutions are plus or minus 1 based on my graph, because that's where it hits. The y equals 4 line hits my parabola, and the corresponding x values are negative 1 and 1. Now let's go do it algebraically really quickly and see what happens. Let's take part B and let's go isolate the x squared quantity. That's going to be negative 2x squared equals negative 2. Divide both sides by negative 2. X squared is equal to a positive 1. And if I go ahead and square root both sides, watch what happens. I get the answer that I got graphically, plus or minus 1. So this time my graph was pretty accurate. At the custom pizza shop, you can buy their special smoked chicken pizza in any size you like, and here's the cost given based on the radius of the pizza. So I guess the bigger the pizza is, the bigger the cost will be. First we have to complete the table using these values of r. So I just put them in. That's basically 1/4 with an r value of 0. Remember, you go right here and you put it in. Squared, that's just going to be 0. And the next one I put 1/4 with 1 squared, which is just 1/4. So I can approximate that as 0.25. Then in the next one I put 1/4 2 squared. Well, 2 squared is 4, and 1/4 of 4 is 1. So I go through all of that and I fill the rest of the chart. So having gone through some computations, I've spit out all the cost values based on the radius of the pizza. So a 14-inch one will cost $49, it looks like. Part B says, how much does a pizza of, actually I have to graph it in part A too. So let me go graph these ordered pairs. 0, 0. Then I have 1, and these go up by 1s. 1, 2, 3, 4, 5. I have 1 and only a quarter of the way. Notice these goes up by 2, I think. 2, 4, 6, 8. Yeah, so those go up by 2s vertically, by 1s horizontally. So I have 0, 0, no radius, no cost. Pizza doesn't cost anything if there is no pizza. So 1 inch is the radius, and then we have 25, a quarter of the way, so really tiny right there. X, hardly unable to get that. Okay, let's just go down to the next one. Let's say, how about $2, or 2 inches is the radius. The cost is $1, so that's right there. And then 6 inches, the cost is $9. I'm just going to pick some of the values. $9 is right there. 10 inches, the cost is $25, so 22, 24, 26, somewhere in the middle is 25. $10. And then 14-inch, that's 11, 12, 13, 14 is 49, so up above here. Notice I'm getting something that's rather curvy and not a line, so that represents the cost in terms of the radius, or the radius of the inches of the pizza. So I'm going to connect these with a curve. So I've connected them with a curve. It's just an approximation, of course, because I didn't do all the ordered pairs, so this is a sketch to the best of my ability. It says, how much does a pizza of radius 3 inches cost? Locate this point on your graph. Well, the r is 3 inches, the radius is 3 inches, so at 3, it looks like it'll be maybe $2, maybe more than $2, so maybe approximately $2. If I really want to know for sure exactly how much it costs, I can just go ahead and use my equation. I put 3 inches in and I get square that, it's a 9/4. So that looks like it's $2.25. So not so bad. We were pretty close. 3 inches costs you more than $2, approximately $2, $2.25 to be exact. Use your graph to find how big a pizza you can get for $16. Okay, so $16 has to do with the cost, which is the vertical axis. So I'm going to go to $16 on the vertical axis. It was going up by 2's. That's 12, 14, 16. So 16 bucks is right there, and I'm only approximating. It looks like the X value there is going to be 8. So maybe an 8-inch pizza? I don't know. That's actually just a guess based on what my graph shows. Maybe my graph is accurate, maybe it's not. Now, how can I do part C algebraically? To be sure, I can go use my equation right here. $16 is the cost. I'm going to multiply both sides of this guy by 16. It's going to be 64 equals r squared. And if I square root both sides, I get plus or minus 8. But since I'm talking about a pizza, and it's got a radius that's positive, look at that. 8 inches is what I had guessed, even by looking at my graph. Right here, there, $16 cost corresponds to an 8-inch pizza. So that was pretty good. What does the 0.69 tell you about the pizza? Well, the 0.69, which happens to be right here, tells me that a 6-inch pizza in radius, of course it has to be the radius of the pizza, costs $9 to get. So the graph displays all the different costs that I could have for the different radii of the pizza in inches.